Okay, hello, YouTube, Reddit, Internet, whoever. This is my RAM that I showed you in the last video. And I said my next project was working on a RAM module where every register had the exact same response time, because that simplifies a lot of things. And so, by the very nature of these registers, I couldn't do that. Because the input passes through to the next one, and then the outputs pass through all the way down across the bottom and propagate to a single output line, and the same with the inputs. So that would mean this one has a 2-tick longer response time than this one, and that's obviously not going to work. So I used a slightly different design, and I saw Ohm's design for RAM like this, and I modified his memory cell design, and I got this. This is inverted. This is your right bit, the cyan. The actual gray itself is the memory cell, and the blue here is the read bit, and yellow is your input. So input's off, press this, nothing happens. Input's on, press this, it writes a 1, and then if we're reading, it'll read the 1, otherwise it's ignored. And the way this works is this is a multiplexer, so the data either goes here, or it goes here. And that controls which piston the right bit is routed to. And that just moves this block back and forth, controlling the state of the output. And then I made these spirals, and the cool thing about these is each one of these is 4 blocks tall. You can stack them directly on top of each other without interference, and directly next to each other without interference. So you power any one of these, and the output gets powered in only a single tick. So if I go up here and I power the top one, it powers the output in only a single tick. And because I wanted to use these, because all the outputs are ORed together effectively, that's why I had to add a read bit onto these. And so I went through several designs. This right here is the 4th version, and the fastest one yet. And the way it's constructed gives each register an equal response time. I didn't have to play with repeater settings very much to give them equal response times. The only time I had to do that was on the output, which are these green buses, which obviously I could do these a lot more efficiently, namely by just wrapping them over the top and then ORing them together in the top, which would get rid of all this crap here. But that's maybe from version 5. And so right now, yellow is your input, and I built this and I copied it over to here, then just added some multiplexers to the read and write bits. And then what you could do is, once you get all of these coming out here, I could copy this entire thing, flip it around 180 degrees, or just directly flip it, would be easier, and paste it, and then put another bus like this, going through the middle of these two, or going through the middle of 2 of these modules, and then keep doing that and kind of make a tree design, and every time I do that I double the amount of memory available. Now this here is, it's very large. It's about as big as 3 or maybe even 4 of these modules here. These are 8 bytes each. Each one of these towers here is 8 bytes of memory. So this here is only 16 bytes, so this is half the size of that in terms of memory, but in terms of physical size, it's about 3/4 as large. So it is larger, and your outputs go in here in the control panel, and yellow is your inputs, and each one is split between left and right here, like that. And then they come in here, and they spiral up or spiral down. It's the same thing as the output spiral, just in the opposite direction. And they plug into the input of each register. Your write bits come through here. Read bits come through here, or inverted in the middle here. And then they come out and go into these ridiculously wired multiplexers, which are not wired very well at all. But it was the best I could do at 2 in the morning. And pink is your first destination bit. Orange is the second. That's magenta, sorry. Pink is the third. And red is the fourth, which I just kind of added these as a last minute thing. And the bottom, these just choose from left and right. And if you could look at these further out without all this other crap in the way, they're kind of like a tree where it'll either, this chooses between the top 4 and the bottom 4. Then if you're going to the bottom, this chooses between the top set of 2 and the bottom set of 2. And then these choose between the first one and second one in each of those sets of 2. And so let's try it out, because I know that's what you want to see. So I'm going to turn the read on so we can see our results as fast as possible. You can see right now the read bit is going down here, and the bottom register on the left side is reading, and all the other ones are not. So that is register 0, and then the last register is the top one on the right side. And so, once again, the orders of these are reversed to keep the LSB on the right side. Let's just write the number 5, I suppose, to register 0. And it's a much faster response time than the other one. This is the fastest one yet, but there's still a lot of optimization I need to do. Obviously I can change my inputs, nothing happens. Going to write again, and they all turn on. Notice they all turn on at the same time as well. That's because of what I did with these outputs. I'm going to switch to a different register, and write a different value to that. So it's pretty fast, and if I flip these off, now I can go back to the first register, the value is preserved, and 0 it. Looks like that one might be one tick behind. Go back to, that was the 0th register, this is the first register. 0 this one, and I'll do some stuff on the right side. Go to the last register, which is that one up there. That's strange, this one didn't seem to write. No, it's not that one, it's bit 2 that didn't write. Wait, no, bit 0 didn't write. Well, it seems to be it's probably a problem with this bus, which looks like it reached up here. This register 0, and looks like it was written. Oh, that's why. That's strange. Oh. I feel dumb now. I left out a wire there. Yeah, so it did work fine. The output just didn't propagate. Turned read off, and it ignores the contents of the register. But what I was going to show you is up here. That's why I wrote to this one. So you can see where the inputs are on. These are out. So the data is routed to here, which will push the block that way. So if you look at these gray blocks right here, for the ones that are on, they're pushed that way. The ones that are off, they're pushed this way. Go go back down here and zero the register. So thanks for watching. Like, comment, subscribe, whatever, if you want to. Not going to force you to. But yeah, so thanks for watching, and I'll put a schematic file in the description.